Good morning, good afternoon, everyone. I am Karla Luna from the State University of Paraíba in Campina Grande, Brazil. And then I am going to present partial results from a big project called an online system for detecting snake venom based on a surface plasma resonance sensor. As everybody here knows, snake envenomations are a neglected tropical disease characterized by clinical aspects that may depend on amount of venom, bite site, age of the individual, and time from accident to the hospital. Those clinical aspects englobe also severe paralysis, bleeding disorders, and local tissue destruction. Around 5 million people get bitten by snakes annually, and around 3 million develop clinical illness. From 81,000 to 138,000 die from complications, although those epidemiological data are still inaccurate. Victims comprise mainly rural workers, including children from developing countries located in tropical regions. In 2017, WHO included snake envenomations as neglected tropical disease because they have in common the fact that threaten poorest populations with difficult of access. In South America, Brazil shows the highest incidence of snake envenomings, with northeastern and north regions being the most affected. Accidents are under notification, and epidemiological and clinical data available are generally poor and show low quality. In Brazil, venomous snakes comprise two main families, Viperid and Elapid. And Viperid family is responsible for the majority of the accidents, with Bothrops snakes being the most important from the medical point of view, together with Crotalus snakes. Bothrops snakes venom shows proteolytic, coagulant, and hemorrhagic activities, and the treatment for those activities is the commercial antivenom. Even though circulating venom can be neutralized by the antivenom, it is not effective for local lesions. Also, mistreatment is a lot referred. It must be considered for treatment, specificity of the antivenom, speed, and amount of injection. Thus, it is clear that the development of rapid tests able to minimize errors on this data are important to reduce mortality and morbidity arising from this type of grievance. Biosensors are devices that make biological signs measurable. They use elements with high specificity as enzymes and antibodies. Biosensors based on SPR phenomenon works like they have a glass prism surfaced by a gold film where molecules are added. When those molecules are added, reflected, we can see a change of resonance on the surface, and the reflected light is detected to produce curves that we can analyze. In this experiment specifically, we used as bioreceptor Bothrops antivenom, commercial antivenom used in Brazil. For first sample, Crotalus venom, and second sample, Bothrops venom, in order to evaluate non-specific link between Bothrops antivenom and Crotalus venom, and evaluate specific link in real-time responsiveness between Bothrops antivenom and Bothrops venom. The objective of the big project is the development of a new methodology based on SPR venom to detect the envenoming caused by Bothrops erythromelalus snake, which is species endemic in northeastern Brazil. Our results showed that Crotalus venom wasn't able to cross-link to Bothrops antivenom in different concentrations. Although, as expected, Bothrops venom showed high refraction indexes showing specific link to Bothrops antivenom. The same pattern was followed when we used even very, very low concentrations. So Crotalus venom showed almost no refraction indexes, even injected to the system before Bothrops venom. And as you can observe in this, this first left graphic and right graphic, both concentrations were able to elicit a responsiveness, a response from the equipment, from the system. So that we concluded that the study showed the analysis of the dynamics in real time of the interaction between Bothrops antivenom and Crotalus and Bothrops venom, showing the biosensor responsiveness to different concentrations of both venoms. It was also showed the capability of the system methodology to discriminate between Bothrops and Crotalus venoms, showing specificity of the system. It was possible to identify a minimum Bothrops concentration capable to generate response or refraction indexes on the biosensor. Considering the impacts caused by snake envenomings and the limited number of research that aim the detection of this health problem, it is necessary to continue with the research now using biological fluids from envenomated people to validate the methodology and also determine the amount of repetitions the biochip can be used without loss of sensitivity. The research is now using other sera and venoms. I would like to thank my team, thank all the sponsors, the State University of Paraíba, Brazil, the Federal University of Campina Grande, Brazil, and to thank you all, the audience.
Great, thank you very much, Karla, for the great talk.
Thank you.
Any questions in the audience? Okay, any questions online? Please unmute yourself.
Hi, I'm Siddharth from India. Can you hear me?
Yes.
I just wanted to know how much time does this take? As in, like during the hospital setting, it needs to be detected faster, right? So I guess this might take some time to detect the venom, right?
I think your connection is unstable.
Sorry about this. Can you hear me clearly now?
Yeah, you are asking me the time between the accident to the hospital people take?
No, I was asking like how much time does this assay take to detect the venom?
Couldn't understand.
Sorry,
Maybe
I'm asking how much time does this assay take to detect the venom?
Oh, it's to detect the venom a few minutes. It's real-time detection.
Oh, okay.
I mean,
Okay.
a few minutes, I mean, not more than 2 minutes.
Okay. And do you need a bigger machine? Like, I think this is a expensive machine. So
no, it's not. I mean, the golden chips cost less than $1. And we are now working on a bigger equipment, of course, at the lab, but we can miniaturize to the size of a cell phone.
Oh, this is great. Yeah, thank you.
Yes. Thank you too.
We have a question here. Just a minute.
Hey, Christopher from Technical University of Denmark here. I was wondering, can you, with this technique, can you also quantify how severe the envenoming is so you can adjust the antivenom?
We don't know yet, but I believe so, because next year we are going to use blood samples from envenomated people. So those blood samples we could quantify, and also because of the results we are showing, you could see in the last concentration using 3 micrograms, 3 micrograms, the biosensor was capable to make a response, to show a good response and specificity. And from that results, it's we believe it's possible to.
All right, thank you.
Thank you.
Any other question? Okay, thank you, Karla, very much.
Thank you, Rita.
That was
Thank
a
you
great,
all.
great talk.
Thank you.